Let's talk about programming languages. Assembly. Initially, all programs were written in a binary, so-called assembly programming language, where you literally instruct CPU what to do within ALU. While assembly, by being low-level programming language, provides very fine control over ALU, it requires programmers to actually know CPU architecture and binary logic. It's very hard and expensive. Assembly provides low-level optimization that benefit execution performance. Example of such programs that have been developed and actively maintained are sorting algorithms, hash functions, loops, etc. So to reduce complexity and improve efficiency, smart people invented high-level programming languages. The purpose of high-level programming language is to simplify the procedure of writing business logic using human-readable text. High-level programming languages are classified as compiled and interpreted. Compiled programming language. Compiled programming language translates high-level human-readable code into machine code during compilation procedure. A program that does actual compilation is called compiler. It's worth mentioning that each program needs to be compiled to specific computer architecture. Programs compiled for x86 will not work on ARM processors, and vice versa. So compilation for specific architecture is required. Compilation is an irreversible process. You can't reliably convert assembly code to high-level source code. Performance-wise, in majority of cases, compiled programs do execute faster than interpreted programs. Majority of compiled languages are statically typed. Explanation follows. Most popular compiled languages are C, C++, Rust, Objective-C, C#. Statically and dynamically linked libraries. Applications can perform certain typical actions such as display images, uncompress archives, and many others. While it's possible to write all such functions from scratch, it's impractical to do so. For that purpose, libraries are used. Libraries help to reduce complexity of development process by splitting application into modules. New features and bug fixes can be performed within the scope of module rather than the whole application. The process of integrating libraries into the main application is called linking. Linking can be done dynamically, meaning that all libraries are compiled separately and connected to the main application during the runtime of the application. Or statically, meaning that all machine code of the libraries is integrated into main application binary. Dynamic libraries usually have extension .dll for Windows and .so for Unix. Interpreted programming language. Interpreted programming language translates high-level human-readable code into machine code during execution of the program. The program that does that is called an interpreter. Since an interpreter is also a program which is already compiled for specific architecture of the CPU, it can translate high-level code into machine language on the fly. Performance-wise, in majority of cases, interpreted programs are slower than compiled. Most popular interpreted languages are Python, JavaScript, PHP, Ruby. Typization in programming languages. Programming languages can be classified as statically and dynamically typed. In statically typed programming language, all variables and data structures are predefined before compilation or execution of the program. For example, this means that if the developer defines variable a as a string, he cannot change its value from string to number later in the code. This can be verified during ahead-of-time compilation and print logical error. This simple technique helps to reduce number of errors during execution, which leads to more stable programs. In dynamically typed programming language, variables can be reassigned from one type to another. For example, a variable a can first contain a number and later can contain a string. That method simplifies development process. Data structures. Variables. Variables can be integer numbers, floating point numbers, strings. They are considered to be the simplest possible data structure. To dig deeper, variables are stored using specified addresses in the RAM. Address is a binary number of memory cell in RAM, usually represented as a hexadecimal number for ease of reading. Constants are special variables whose value after assignment should not be changed by the running program. Besides variables, there are other data structures such as arrays, associative arrays, linked lists, queues, stacks, and many others. The purpose of these structures is to store data more efficiently, so it would be easier to work with. Functions in programming languages. One of the ways to simplify programming of business logic is to use so-called functions. Like in math, where f of x is a function that produces some value depending on the properties of that function, in the programming, functions can return values or do some stuff. Functions can accept input arguments such as a number, a string, or any other data structure. and return values or data structures, or they can work without any arguments at all. Everything depends on the business logic of the function itself. That's it. Now you know more about programming languages. If you like this kind of stuff, check out our blog, link in the description. Like and subscribe.